Hello everybody, let's quickly discuss a geometry problem. Okay, we're given a rectangle ABCD. Okay, and we're given a diagonal AC, BY perpendicular to AC, YX perpendicular to AD, YZ perpendicular to CD. The length of DX is A, the length of XY is B, and we are also given a length of AC, the diagonal of the rectangle, to be S. Okay, and under these given conditions, we're supposed to show that S raised to the power 2 over 3 is equal to the sum of A raised to the power 2 over 3 and B raised to the power 2 over 3. Okay, all right. Now to solve, or in order to prove this thing, let's make some additional assumptions. First, let's suppose that this angle is theta. Okay, this angle is theta. Then, since this line is parallel to this line, we're going to get this angle to be theta. Okay, this angle to be theta. And again, as this line is parallel to this line, we're going to get this angle to be theta. All right. Now, since this is theta and this is 90 minus theta, and as this is 90 minus theta, this must be theta because this angle is 90 degrees. All right? Okay, that's the first assumption. Let's make another assumption that AD is equal to X. AD is equal to X. And that CD is equal to Y. Okay, CD is equal to Y. Then this length AX is equal to A minus X, and the length CZ is equal to Y minus B, because this is B and this DXYZ. This is also a rectangle, which means DZ is equal to B. The whole length is Y, so we're going to get CZ is equal to Y minus B. Okay. Now, opposite sides of a parallelogram are equal, and rectangle is also a parallelogram, so BC is equal to X. And similarly, since AB is parallel to CD, okay, we're going to get AB to be equal to Y as well. All right. Yeah, now we also assume that this length is M and this length is therefore S minus M, because AC is given to be S. Okay, all right. Now, in order to show this, let me just erase this. Okay. Let's look at triangle ACD. Okay, triangle ACD. We're gonna obtain the values of sine theta and cosine theta from this triangle. Okay, ACD. This triangle means ACD, right? This was X, this is X, this is Y, and this whole diagonal was S. So sine theta is equal to Y over S, and cosine of theta means X over S. X over S. This was theta. This is theta. Okay. Now let's look at this triangle. Triangle ABY. Triangle ABY. Okay. Then we get sine theta is equal to opposite side of theta is equal to M, and the hypotenuse is Y. So yeah, And since we don't really have assumed length of by to be anything, we're not going to calculate cosine of theta from this triangle, okay? We can, but we're not going to. Triangle, now let's look at triangle BCY. We can calculate cosine of theta from this triangle, okay? Cosine of theta. So the adjacent side is s minus m and the hypotenuse is x. All right? Okay. Now, from sine theta, these two values of sine theta, we get y over s is equal to m over y, which means y square is equal to ms. Let's call it equation 1. And from these two values of cosine theta, we're going to get x over s is equal to s minus m over x, which means x squared is equal to s times s minus m. Let's call it equation 2. We're almost done. Now let's look at the smallest triangle over here, triangle AXY. This is theta, this is a minus x, and this is m. We can directly calculate, we can calculate sine and cosine from this triangle and also from the upper triangle, okay? Now let's look at this triangle as well. This is theta, this is a, okay? Since dxyz is a rectangle, and since dx is equal to a, the side yz is also equal to a, okay? It's a, and this length is y minus b, and the length yc is equal to s minus m. This was triangle AXY, and this is triangle YZC. Okay, now let's look at these two triangles. Yeah, let's look at triangles AYX. From triangle AYX, we're going to get sine theta is equal to b over m, and cosine of theta is equal to a minus x over m. All right? Okay. From triangle CYZ, we're going to get sine theta to be equal to, will be equal to y minus b all over s minus m, and cosine of theta is equal to a over s minus m. Right. Now from these two values, we can equate these two values to obtain b over m is equal to y minus b over s minus m. Okay. Now let's cross multiply. bs minus bm is equal to my minus bm. So we can cancel out minus bm with minus bm, which gives my to be equal to bs, right? But we have the value of y squared, and we're getting y over here. So let's square this equation, okay? Let's square this equation right here. Let's square this equation, so that we can use this value of y squared. All right? Okay. So let's square this equation on both sides. M squared y squared is equal to b squared s squared, which would mean m squared as it is. M squared is as it is, and this means ms y squared is equal to ms, and b squared s squared as it is. So we get m cubed is equal to b squared. We can cancel out one of the s's because s is not equal to 0, since s is the length of AC. It is strictly positive, right? So b squared s, okay, b squared s. So we can say m is equal to 2 over b raised to the power 2 over 3, considering only real values of m, because m is a length of a line segment. Okay, so let's call this equation 3. Let's call this equation 3. Now, to obtain another equation, we're going to use the two values of cosine. Okay, the two values of cosine, which means we're going to get a minus x over m to be equal to a over s minus m. A over s minus m. All right. So this means am is equal to not a minus, oh no, this is x minus a, right? Oh, x minus a. So this is x minus a. X minus a. I'm sorry, I'm really sorry. X minus a. So multiplying these two terms, we're going to get x times s minus m minus as, a minus a times s minus m. Okay, we're going to leave it as it is, so that we get am is equal to x times s minus m minus as plus am. All right, and we can cancel out this am with this am, so that we get x s minus m to be equal to as. All right, we did not expand this term, we didn't multiply, we didn't distribute x in this product, because we're going to use this, and it involves s minus m as a factor. Okay, now just like in this equation, we're going to square this equation. Okay, so we're going to get x squared s minus m squared is equal to a squared s squared. Why are we squaring this? Because we have the value of x squared. Okay, we have the value of x squared, and here we have only x. So in order to use this value of x squared, we are squaring this equation. All right. Okay, now let's see, we can use this value, x squared is equal to s times s minus m, and this s minus m remains as it is, and we're going to get a squared s squared as it is. Now we can cancel out one of the s's just like before, and this is s minus m whole cubed equal to a squared s, which means s minus m is equal to a raised to the power 2 over 3 s raised to the power 1 over 3. Okay, all right, let's call this equation 4. Now we're getting b raised to the power 2 over 3, a raised to the power 2 over 3. Okay, we needed the sum of these two quantities to be equal to s raised to the power 2 over 3. Now, to obtain this sum, the sum of these two, let's first add these two equations, okay? Add these two equations, and let's see if we can cancel out a power of s, okay? Now let's see. 3 plus 4 means m plus s minus m is equal to b raised to the power 2 over 3, s raised to the power 1 over 3, plus a raised to the power 2 over 3, b raised to the power, s raised to the power 1 over 3. Okay? We can cancel out these m, and so we get s is equal to a raised to the power 2 over 3 plus b raised to the power 2 over 3, and the common factor in both the terms is s raised to the power 1 over 3. Now we can divide both sides of this equation by s raised to the power 1 over 3, and therefore we obtain s raised to the power 2 over 3 is equal to a raised to the power 2 over 3 plus b raised to the power 2 over 3, which was what we were supposed to prove. Okay? Alright, this much for today. Thanks for watching, and take care of yourselves.